All right, welcome. Hello, everybody. Come on in. Very good. The first row is always so intimidating. We have an incredible panel for you. We're super excited about this section of Georgia Technology Summit. So welcome to Leveraging Machine Learning and AI for Strategic Advantage. I'm Dr. Beverly Wright. I'm the head of data science at a company called Burtch. Other affiliations, I'm the chair for Data Science and Analytics Society with TAG. I'm also the president of Analytics Society at Informs. Let's see, what else do I do? Oh, I run the Executive Data Science program at University of Georgia. Go Dogs! But I'm also on the board at Georgia Tech, so I don't know. And I run a podcast called Tag Data Talk. It's one of the top podcasts in the world. We're in 140 countries somehow. Can you believe that, Ken? Crazy. You were on Tag Data Talk at one point. So that's probably why, because Ken Viciana, hashtag Viciana Data, was on Tag Data Talk. So please take a listen and get involved with Tag Data Science and Analytics, as well as Tag Data Governance, which is Ken's group. So with that, we're going to go ahead and start our introductions. You got one. Oh, okay. Cool.
Can you guys hear me? Okay. So I'm Kumar Menon. I am the CTO for Data Fabric and Decision Science Technology at Equifax, which is pretty much our entire value chain of how we bring data in and deliver our products to our customers.
I'm Monica Ellingson. I lead the sports and entertainment practice for IBM Consulting, and we've worked with some of the preeminent brands in sports. Over the last 26 years, our portfolio consists of Masters Golf Tournament, US Open, Wimbledon, ESPN Fantasy Football, and others. And we're a cross-disciplinary team. We really deliver the full project lifecycle. And our mission overall is to deliver excellent digital experience in sports and showcase IBM's capabilities.
Awesome. Monica, I look forward to seeing pickleball in there somewhere.
Hey everyone, thanks for the opportunity to talk today. My name is Steve Latham. I'm the founder and CEO of an Atlanta-based company called Banyan Technologies. It was founded in 2013, started the company with the idea that we would build a remote monitoring and management platform to drive automated outcomes for distributed device networks.
Good afternoon, everyone. My name is Dutt. I'm the Chief Digital Officer of Celsior Technologies, part of the Pyramid Consulting Group. We help our customers solve their problems today while we prepare them for a digital tomorrow. My part-time, I'm also a technology futurist and part of multiple forums in the United States that envision and start predicting technology and the technology trends. Look forward to the discussion today.
Hi, I'm Michael Lugo. I'm a principal data scientist at AT&T in our chief data office. We're essentially sort of, for the most part, an internal consulting organization. So we solve problems that are coming to us from throughout AT&T. Mostly right now, I'm focused on forecasting and optimization for our call center. So basically, you don't want to call us. You really don't want to call us back. So we are trying to improve that. And look forward to hearing what this crowd has to say.
Hey everyone, I'm Mark Jackson. There is an extra K in my name that's missing there. But I'm the Executive Director of Business Intelligence for Piedmont Healthcare. I've been in that role for 11, 12 years now. When I started at Piedmont, we were 4 hospitals. We're 22 now with over 1,000 physician practices, so tremendous amounts of growth. Responsible for our BI platform with Tableau, our XSL data warehouse, and our machine learning platform with DataRobot.
Awesome. What an incredible group, right? And what diversity. A little fun fact to know and tell. Mark Jackson, you were my first actual speaker, the person I got, because usually I just did it myself because I didn't want to have to twist people's arm. But you were my first actual speaker about 10 years ago. So thanks to all of y'all for being here and for your service to the community by contributing here. Can we advance? Thank you. So we're talking about the changing role of data scientists in light of these emerging technologies and AI capabilities, which is a subject that is going to probably affect all of us at some point in time to a certain extent. So we're going to start off with this first question where we're talking about how a data scientist will modify and how this will change and what that transition will look like in light of AI capabilities. Our first question for you guys is, what are some of the emerging technologies that impact data science? So tell us just what some of those are.
I'm sitting here holding the mic, so I guess I'll go first.
Okay.
Obviously, ChatGPT is top of mind for everyone, and I think it's going to have broad-ranging impacts for data scientists as well as just my traditional developer types that can leverage it to help them code things that they've never coded before. For example, I don't have any experience with standing up web servers or using D3 for visualization. We're a Tableau shop, I know that very well, but using ChatGPT, I had a web server set up with Python, leveraging D3, querying my data warehouse directly all within an hour. So I think this platform or this large language model capabilities is really going to transform the way people work as sort of a creative assistant for everyone, data scientists, your traditional developers, physicians, et cetera.
Yeah, so I think I have to answer ChatGPT. I think it's sort of it's May of 2023. This is what you answer to this question. But seriously, I think that it's I've played around with it a little. We've actually built an internal version of ChatGPT that we are really hoping will be useful. So you not only does it have external data, but we're hoping to be able to train it on internal data as well and use it for internal use, which at a company the size of AT&T, we have many data sources, none of which have any documentation. I never have any idea where any of the data is at the beginning of a project. I feel like I can admit that because I'm sure everybody else is the same. One thing I would like to see is really that sort of thing being useful, not necessarily for writing code, but really for sort of knowledge discovery in the enterprise. Knowing what's going on, knowing what sort of being able to get started on a project more quickly, knowing where the data is, what it means, as opposed to having to schedule endless meetings with people that don't really want to talk to me. So I would like to see that.
What other emerging technologies are impacting this besides obviously ChatGPT?
All right.
Yeah.
So, as a futurist, I coined a term called TAE, T-A-E, or thought-activated events, right? And just yesterday, there was a publication where some of the scientists have developed a ChatGPT-like AI platform, right, that integrates with functional MRI that can convert your thoughts into text. Imagine what that can do to the world. Imagine how that's going to drive. All I got to do is think about it, convert that into text, feed it to a UXML, generate the code. It transformed the entire IT. It transformed the entire world. Now think about that. And data science in that context is going to be very different in the next 3 to 4 years or in the next 5-year horizon. Data scientists and what we ask them to do will probably more of an architecture work and the ability to deal with this multitude of models and platforms that will start positioning them as subject matter experts and process experts and not that much of technology experts. I know this is a technology forum, but that's coming.
That's why we're talking about it. Yeah. What are some of the other emerging technologies that could impact us? Yeah.
One of the things that we're focusing on at in IBM Sports is computer vision. So, in addition to using large language models to generate, from data to text and then ultimately text to speech, we're able to, for example, use computer vision to watch the individual joints of a player on a tennis court and be able to identify, through some of the scoring and just traditional stats, of course, what's happening on the tennis court and where the actual tennis players are located. But through the watching their joints, you can, and where they are on the court, you can effectively tell the story of what is happening within a sport. So whether it's tennis or golf, being able to watch a player through computer vision and then generate, what is the overall commentary? What is the story that's going on? So for example, at the Masters Golf Tournament this year, we rolled out, phase 1 of our AI commentary solution, which looked at, stats, performance, player data, course data, as well as large language models from, to convert data to text and then ultimately text to speech to auto-generate commentary for over 20,000 single shot highlights for every player, for every shot that they made over the golf tournament. So that's phase 1. But imagine if you could put computer vision on top of that and actually watch the player and what their movement is. Is it a top spin shot in tennis? Is it an underspin? What does that mean to their game, and what does that mean in terms of predicting their performance?
Okay.
Yeah, no thanks. The other thing that I think is important is we can look at the machine learning algorithms and the evolution that's happening there, ChatGPT, as was discussed, but those algorithms can only be as smart as the inputs or the integrations that are happening with them. So what we're seeing is a lot of innovation in terms of instrumentation of the devices, of the systems, whether they're business process or edge processing devices that are out in the wild, the ability to instrument them easily and then integrate them into these systems so that we can derive the insights and drive the outcomes is a place where I think we'll see accelerated innovation.
Mm-hmm.
Of course, large language models, Gen AI capabilities have made a big impact. But it's also impacting the full stack. When you look at the compute architecture that is being provisioned these days by the hyperscalers, significant change in the technology. The chipset is changing. The precision values of the chipsets are changing to be able to accommodate these massive computations, billions of parameters that these LLM models have to run. You look at the security architecture, which I think is a very important change in the ecosystem as people are getting more and more fancy with data and as using secure data, as using highly sensitive data for making decisions. The security architecture is changing. The encryption capabilities around how you protect data, how you can decrypt at real time. I mean, those are some significant changes that are impacting the ecosystem as, Gen AI and other capabilities become pervasive in the organization. And the last thing I want to mention is governance. I mean, the tech stack around how do you govern this ecosystem? How do you know that you have the right data coming into the ecosystem, that the decisions you're making using these complex models are explainable or interpretable, right? Those are important decisions because you're impacting, someone's life, if it's a credit decision, for example, the kind of business that we are in. So how do you make sure that you have the ability to explain, why the decision was made? I think those are some of the changes that I see in the technology landscape that's happening.
Nice. So it sounds like, to summarize real quickly, we've got, of course, ChatGPT that is helping data science with coding and doing things more efficiently. We've got computer vision that's able to see and collect data that we had never collected before, whether that's optimizing a player or understanding a consumer or improving the efficiency of your operations. We've got other kinds of things like generative AI that is helping with the data science world, and all kinds of things. Nobody mentioned IoT necessarily, but I'm sure that would fall in that category. And the thoughts, you were talking about the thoughts, the closest thing I can think of is there's a company, they got bought out, so now I don't know the name of them, but they used to be called Convergent in Alpharetta, and they have this camera system that's used in lots of retailers, including the Home Depot. And if you look at the camera, do y'all see those little kiosks when you're trying to find the stinking sink, and it's like so hard to find just the right sink? You want 2 handles, it's got to be color, it's got to be this color. And so you go to the little kiosks, those kiosks have a camera. And that camera is assessing your face on 14 different dimensions. It's not just saying you're happy or you're confused or you're irritated. It's looking at your degree of happy, your degree of confused, your degree of irritated. It's also measuring what you're touching on the screen. So those kinds of things with computer vision and other sorts of systems that are monitoring potentially even our thoughts that get into the system and change that into data. So lots of different AI technologies that we've talked about. How are these types of technology advancements helping or even potentially hurting the data science world? We talked about improving coding. We talked about collecting data that we couldn't collect before. What are some of the other ways that these technology advancements are really helping or hurting data science, but also us as a community?
I think a lot of this goes into the realm of a solution looking for a problem. That scenario, of course, when new technologies come in or new techniques come in, that's always something that you have to watch out for. But I think the biggest I think the impact is more positive than negative in my mind. People have started understanding the value of data as a result of this. There is a lot more awareness about how you want to use secure, governed data. There is a lot more around how do you leverage these techniques internally to become more and more optimized. Whether you're looking for operational efficiency, you're looking to improve your security posture, how do you use advanced techniques to actually get better at delivering your products to your customers. And then, of course, the interaction model with your customers changed completely as a result of this. You're talking about a chat experience with your customer as opposed to very transactional. In many industries, it's very transactional. So how do you change that experience? So I think overall the impact is positive, but you just have to make sure that you have the right strategy in place before you embark on these.
So when you look at the how are these advancements impacting, but let me make sure that we have the foundation clear. Your AI model is as good as the data that goes into it, as good as the data that we are cleansing and putting in, right? Now, think about applying AI to your data cleansing itself. And then your data collection from whether it's an IoT device, right, or leveraging the concepts of a cloud-based computing or edge computing or quantum, to that matter, right, has really enabled the ability to go into the minute levels of analytics. And that has really transformed the data science from the ability to build the capability to compete on analytics, if not anything, right? Now, how do you orchestrate all these things? Yes, we need the right governance, we need the right operating model, we need the right security model, and you need the ability to deliver better, faster, cheaper, and secure, right? So how do you pull these things together? How do you make sure that you are bringing these together is an uptick in the entire AI models and the use of these AI models for a business strategic advantage. There are multiple disadvantages too. You talk about bias, right? You talk about, the model, the limitation of the model given multiple sequences. So to give you guys an example, in my prior life where I was a CIO of a global fintech, we used to process about $1 trillion of post-trade every day. Now, whenever there is a variation, the AI model failed. And the machine learning was not fast enough for us to look at all those modifications, especially during COVID, when the fluctuations are very high. So how do we fix those? How do we build those? And I think the new edge, quantum, and the cloud-based architectures or the polyglot architectures will help resolve those. That's my take.
The other thought,
Can I just, isn't it great that we're still talking about GIGO? Like 30 years ago, I started in this field and we were talking about garbage in, garbage out. Doesn't matter how much we advance, it's still going to be a thing. I'm glad you mentioned it. Yeah, Steve, right.
The other thought that I have just in helping and hurting, I think data scientists have so much opportunity right now. I think to resist or to resist the urge to embrace this change is futile, I think, for a data scientist. I think figuring out how to embrace it and apply it to your specific areas of focus is paramount. It's here, it's moving quickly, and it's only going to speed up. I think the pace at which this innovation, this technology is going to accelerate will probably outpace anything we've experienced. And so I think you have to sort of grab the reins and start thinking about how to apply it. The garbage in portion of it, you were talking about that earlier, you have to pay attention to that. But also the garbage out, I think there's a huge opportunity around establishing trust for the conclusions and the outcomes that are being spun out of machine learning right now. We've already seen lots of examples in the news about, I queried ChatGPT and got the response that was ridiculous. I think there's an opportunity to wrap systems and thought processes around, okay, how do we create validation to what these systems are doing for us?
So I think that one thing that comes out of this is that as we have more and more predictions coming out, we have these sort of black box models. I'm finding that a lot of the time the business partners that I work with don't really want a black box model. They want to have some idea what's going on inside. And so I think explainability is really important. And I don't know if you really call that a technology or more of a set of ideas. But I think in some sense it's technology because you come with explainability. You come with explainable models. You have to train surrogate models. Do more computation. So you do have to make some, you do need better compute in order to be able to do that. But I think that a lot of the time, and like I said, we're sort of a consulting organization, and so our business partners are a little bit skeptical. They're like, okay, what do you know about our business? So they sort of want to see that what any model that we give them is doing agrees with their intuitive knowledge of the business, because a lot of these people, even if they're not necessarily, doing quantitative work all the time, they know their operations. They know what they're doing. They know what to expect, and so they want to see that the predictions that we're giving them and the modeling results we're giving them fit with their knowledge. Or if they don't, that we can come up with explanations. They don't want us coming in and just saying, well, we're the data scientists, we know better than you do.
Right.
That's not a way to make friends.
Do you think that AI helps or makes it more complex to explain and have that transparency?
I think so. If you're training a linear regression model, you can say, well, look, this coefficient is positive, this coefficient is negative. There, we can interpret that easily. When you start having even if you have a computer vision type model, you can say, okay, well, the neural network works this way, and first it sees these features, then it sees those features. But does anybody really, have a good explanation of how these large language models work that you can show to, somebody that you might be trying to convince to adopt them? No, or maybe they do, but I haven't heard of it.
Yeah, Monica, I think, and then Mark.
I'd like to build on what you were just saying, and I think that from our experience, in rolling out and trying to develop sports insights and predictions. In the first few years that we were doing this, we were focused more on task-based model creation, and that was actually very laborious work. To train those models, to train them about the specific elements of sports, to ensure that the models were trustworthy and not biased, et cetera. The thing that has been very promising in terms of using the large language models, at least in our area, is that you can spend less time on creating the model and whatever task you want it to perform, and focus more on the domain expertise to apply to that model. And I think that we've actually been able to train a model, at least in golf ontology, in a matter of hours rather than weeks or months. And then for the time savings that we have, to be able to take a step back and spend the time tweaking the output and making sure that it is at the higher level of quality than we've ever had before. So I think it's a matter of embracing the fact that the large language models can be, applied, reused, and then with the time savings to be able to tweak them to ensure that there is less bias, the quality output is also better.
Awesome. Mark.
So I want to mention a few ways that I think that these tools, particularly large language models, will be helpful, and one way I think it'll be harmful. So on the helpful aspect, I mentioned the one kind of creative agent aspect of it and using it to build visualizations in D3 and stand up web servers and things like that. I think it's a productivity enhancer in that way as well. I think especially with AI agents and the things that you're able to do with that, where you have spawns of the large language models that specialize in certain tasks. Like I've seen demos where you have a high-level question about which artist in a kind of music streaming data set has the most listens. And it's a fairly complex model. AI agents that specialize in going and reading the schema, figuring out which tables are likely to be relevant, which fields within that are likely to be relevant, spawning that off into another agent which can construct SQL, and another agent that can check to see whether there's errors and know how to kind of resolve those things. So I think those things are definitely going to be big productivity enhancers. And then another one I think that will be really helpful is just to distill complex information in terms that other people can understand. And a good example of that is one of my team members sent me a message on, I think it was last Friday. And maybe it's because it's Friday, but I'm reading this article about machine learning and certain kind of conceptual document that was written, white paper. And he sent it to me, and I didn't really understand it either, but I threw it into Chat GPT, said, explain this to me like I'm a fifth grader. And it bullet pointed it all out for me. And I was like, okay, I actually understand this. Bullet points 1 and 4 seem to contradict each other, though. And it says, I can see how you could understand that, but here's actually the difference between point 1 and point 4. So that greatly improved my own learning, my own understanding that I probably never would have just figured out on my own. But using this tool, I'm able to distill that complex information in ways that I can consume. You can imagine the implications in healthcare, too, where a physician's speaking to me or I'm reading a discharge summary note and I don't understand that as a clinician. I can get that to read that to me in language that, in terms that I can understand. All the medications that are listed, I can get descriptions of all of those things in terms that a non-clinician understands. So those are things that I think the tool set's going to be extremely helpful in it. I wouldn't use it as a replacement for Google and just like, hey, here's some facts. Although I do think that there will be advancements that you'll have models checking models, and that starts to improve over time. The thing I think that will harm us is the erosion of trust. And I think these models can be used by bad actors to make really convincing misinformation. And I listened to a TED Talk, and I apologize because I can't do the attribution right now, but I don't recall. But the interesting one was they could take a few seconds of someone's voice and use that to replicate that person's speech and then feed it any language they wanted. So they used an example where they were deceiving a mother. They captured some audio from the daughter and then used it to call the mother and said, hey, Mom, I forgot my social security number. I'm applying for a job. Can you help me out? So, stuff like that's going to become, everybody's going to start to become skeptical of anything that's digital, especially in the public space. And unless you kind of control the pipeline end to end of all of the information, I think it's going to be hard to trust some of the public data.
Okay, I know we're we only have a few more minutes. So just to summarize that real quickly, some of the main ways that this AI technology can support or maybe even hurt our data science work are, number one, efficiency. So without a doubt, it can make us do things more efficiently, hopefully. Secondly, the accuracy. Are we good? The accuracy. So are we able to create more accurate models than we could have done in the absence of AI? And then the other things to think about are, is this always going to be a good thing? Like, is it helping with transparency of our model building? Is it hurting with it? And then other factors like, what about the trust issue and bad actors that are able to take and harness this kind of power and use it in a way that we really don't want? So with all that being said, I like the way you said, like, you're mostly optimistic. That was very encouraging. But if you're mostly optimistic about what AI has to offer, and someone else said you have to embrace it. It's kind of futile not to, that we have to move forward. So why is every company not just doing AI left and right? What are some of the barriers that we're running into, and how do we kind of remove them?
We have a room probably largely full of technologists, and I think one of the hard things about being a technologist is you sort of think that it's the center of gravity, and you forget that for something to be adopted, like a self-driving car or a cell phone, a smartphone, there's an entire business set of responsibilities that have to be wrapped around it. So commercial models, regulatory requirements, pricing, those are things that I think it's easy to underestimate that have to be created and thought through. And already with something like ChatGPT, you can see this usage-based model isn't going to work. We have to figure out a different way to integrate with a system like that and take advantage of it. It just becomes commercially not viable. So I think that for an opportunity for data scientists or for people that are trying to make this happen, I think it's to respect the other disciplines that have to be to exist to make it successful.
In my experience, the resistance to adoption is the fear of unknown, right? You do not know what the outcome is. And there's no way to address the outcome unless you change the attitude of the C-suite, unless you change the attitude of the senior management and convince them to adopt or to start looking at newer technologies as a potential viability for them to grow.
So starting at the bottom, sort of grassroots, you're saying with AI tech, it's impossible. You pretty much have to have buy-in at the top.
Well, you need to have both top-down and bottom-up approaches. And the reason why I'm saying that is because because you need to build the talent, you need to build the skills, and you need to build the capabilities that are required to deliver that vision. And a top-down because you also need the buy-in, and how do you start building that path of least business disruption, right? That enables a new technology in the organization and make it a business value and a business differentiation. I think that is the reason why there is resistance to adoption. And if we can tackle that, and if we can, start, and as technologists, if all of us have the ability to build that business value and articulate that business value in English and not in Techlish, I think we'll win.
Awesome. Very good advice. Michael?
Yeah, so if I can speak to that, sort of, you need both top-down and bottom-up buy-in. We had a project. We were trying to do some large-scale forecasting of, just the volume of work that we were going to have, that we were going to expect in certain lines of business, and I faced resistance from both of those, which is why both top-down and bottom-up, which is why we're not using those forecasts. I'm not bitter about that at all. But the top, at the bottom, we had sort of some of the business analysts that were just, really reluctant to even explain to us, what any of the data they were working with meant, because I think they felt that either we wanted to take their job or we were saying that we could come up with better forecasts than they did, and they felt threatened by that. And then on the other hand, the executive that was sort of overseeing the whole forecasting, overseeing our entire client unit, in the end didn't really want our new forecasts, but wouldn't come right out and say this. Instead, just came up with a wide variety of error metrics. Just said, okay, well, all right, it's better on mean absolute error, but have you tried root mean squared? Have you tried weighting the errors? Oh, it's only 70% of your forecasts are better, 30% of them are worse than the ones we already had. And sort of, to some extent, you sort of maybe the intellectual honesty to say, to just say, okay, this is really what I'm troubled with, sort of instead of dancing around it. So
is there a silo? It sounds definitely like a cultural
definitely a silo.
Yeah.
Which is hard, and especially I think right now some of these silos are hard to deal with. By right now I mean in this sort of post-COVID moment, because we're not seeing these people face to face, and so it's a little easier to tell that to people remotely. But even if people do go back to the office, and I don't know what's going to happen there, you have you still have distributed companies. You still have I'm at AT&T. We have people all over the country and the world, and you can't. It's sort of hard. It is harder to build that trust within an enterprise if you. And I think we're gonna have to solve that somehow.
Yeah.
I don't know how. I don't think it's just everybody goes back to the office. I think it's a bigger social problem. But
right, gotcha.
We'll have to figure that out.
Other big challenges, Kumar?
Well, I think you truly have to become a data-driven company, and a lot of companies say they are data-driven by appointing a chief data officer or a chief analytics officer. But do you really understand the quality of your data? Because there are implications of having bad quality and really advanced AI ML capabilities. When you train models with bad data, you have really bad outcomes. So I think really becoming data-driven requires the top-down, push, from the C-suite to really enforce, the quality of the data, the governance around the data. You really understand the regulatory implications of using the data in certain ways. Is your legal department, your compliance department aware of what the implications are? I think bringing the entire organization to change and really adopt that as a culture is I think, the biggest challenge in my mind.
Who's next? Did I miss someone? Oh, you're good. So it sounds like these are y'all a little bit surprised that none of these are like money or technology? Or skills? Nobody's mentioned money, technology, or skills. It's all cultural. So buy-in, silos, trust, senior leadership. These are all the things that are sort of preventing us from being able to advance and embrace AI in a stronger way, in a better way, to help with those mostly benefits that we just talked about, being able to do things more efficiently, more quickly, more accurately. So very interesting thoughts. Can we go to the last slide, please? Lastly, just any final piece of advice that you would give to someone. Like, imagine that all these people are saying, like, I'm ready to go tomorrow. Like, I'm going to find a way. We're going to embrace more AI at my company. What final piece of advice would you give, just real quickly?
So if I could go back in time, I think certainly the biggest challenge that I faced at IBM has been just education. And really getting everyone to understand what was possible with artificial intelligence and machine learning. And the reason that education was so important is that without everyone understanding what was possible, they couldn't imagine. They couldn't imagine how it could be applied. So just to give you an example, 4 or 5 years ago, we were imagining what would be possible when we came up with this idea of a personalized broadcast. So, in the way that broadcast media works for sports at least and for everything else, there are, major producers out there and broadcasters who decide how we are going to enjoy a particular sporting event, entertainment event, et cetera. They have a content plan, a strategy that they start off with, what players or artists they're going to feature, et cetera. What is the storyline that they're going to build? What if you were to actually put in the hands of the viewers a way to personalize and create their own broadcast? So, over the course of 4 or 5 years, just to use the golf scenario, we actually, in year 1, we were able to, all right, well, what's the problem we're trying to solve? If we're trying to create a personalized broadcast, then we need to have enough content to actually create that. And there are not enough human beings in this world to, follow 100 golfers around a golf course, create, individual clips for those, content associated with each of those clips, and then even to feature up for, a user when there is dead air. What is the most interesting action that's happening on the course at that time? So we rolled out, an every shot solution, which captured every single shot for every player. Then we used AI highlights to feature and identify what are the most exciting shots that have been played that day. Then in year 3 or 2, we were able to, all right, we have this massive amount of content that's been generated, through our AI highlight solution. What can we do with it? So we created new highlight packages from it, which never could have been done before, maybe 10, 20 a day could have been produced by individual videographers. Hundreds were produced a day. And then finally, this past year, we added, commentary on that. So not only can you watch it the way you want, you can listen to it the way you want. So I think the goal, again, is just to keep the user in mind, the experience that you want to have, and ultimately, educate so that you can make sure everyone can open their imagination to what's possible.
So Monday morning, how do we start? Here are the 3 things that you need to consider. Number 1, sponsorship and your C-suite and your executive level commitment to drive an AI program. Second one, don't try to automate or build an AI model for an already broken process. Try to fix the process first, right? The third thing is reevaluate your talent, your capabilities, and do you have the right structure and the right operating model to enable an AI-based organization that's data-driven.
Excellent.
Those would be my 3 points.
Excellent. Very good summary. Thank you guys so much. Can we give them a hand? Thank you. And if you want to connect with them on LinkedIn, and I'm sure they're going to entertain some questions if y'all want to step on over here. Thank you.